All right, ladies and gentlemen. So today we're learning about a brand new type of graph called an exponential graph. Okay? The broader topic is exponential functions. This is the third and final type of graph that you have to learn about in Algebra 1. Okay? So let's look up here at these three pictures. This would be linear, right? Straight lines. That was what we started with. And then we learned that there can be these curved lines like this, and they have a mirror quality to them where you could do a mirror fold. They have an axis of symmetry, and they go up like this in all directions up, or they go down. Those are called quadratics. Remember those? Okay. Now today we're learning about a brand new one, and these are called exponential functions. Okay. Exponential functions, they start small and then they get real big. So they kind of look like a hockey stick like this. Or that's called exponential growth. See, because it's growing larger. And then there's this type that starts real big and then gets real small. That's called exponential decay. So the first thing I want you to draw is I want you to draw this. This is decay. This is growth. Okay. Look here. I've told you there are two forms of exponential behavior, growth and decay. And now we move on to the big formula. So back in the linear days, we learned that y equals mx plus b. In the quadratic days, we learned that y equals ax squared plus bx plus c. Right? So this was linear, this was quadratic. And exponential, it's y equals a, open parentheses, b, close parentheses, and then up in the exponent section is where the x goes. So make sure you write down this formula. So you know here we're interchangeably using y and f of x interchangeably. These are the three big things. If you know these three formulas or forms, you know everything about algebra. Can I erase this? Can I erase this? Okay, so there's some things you need to know about this equation here, or this form. This f of x, or y, okay, this is the future value. Write that down. Future value. Okay. This a right here, this is the starting value. And it's also the y-intercept of the graph. Okay. This b right here represents, so this is actually a little formula. So write b equals 1 plus or minus the rate, which we call r. Now there's two types of rates. There are rates, R-A-T-E. There are rates of growth, and there are rates of decay. In other words, something is either increasing by a certain percent every year, or something is decreasing by a certain percent every hour, or something like that. Now this x up here, this is time. Time can be anything. Time can be years, minutes, seconds, weeks. It could be rounds in a tournament, and something to do with time or intervals, okay? So what we're going to focus on for the next few minutes is this, B, because this is where we need to zoom in and focus. So I'm going to give you some examples. First, we need to remember how to convert percent to decimal. So I'm going to give you some examples. 12%, 2%, -5%, 10%, 101%. Okay, we're going to convert all of these. Wait. I want to change this. Instead of 5%, I want to put 3.2%, 3.25%. Okay, we're going to convert all of these into decimal form. Do we all remember the trick? What is the thing? What do? You put a period at the end of it. If there's not already a decimal, you got to put a decimal. And then you move it 2 places to the left. Put the period there. And then any open spaces, get a 0. So here, move it over 2 places. Put a 0. Move it over 2 places. Put a 0. Move it over 2 places. Okay. You don't have to put a 0 there. And then here, look at this one. You move it over 2 places and you're still in the number. So as a decimal, so this is percent and this is decimal. This is This one is done wrong. I don't even know what I was doing. This is 0.12, right? We move it over 2 places. At 12% becomes 0.12. Do you understand? Okay, that was my mistake. I was getting excited about putting the zeros. 0.12. And then here, 2% becomes 0.02. 3.25% becomes 0.0325. 10% becomes 0.1, and 101% becomes 1.01. I'm going to ram this home. Just to convert these back to a percent, you would just go whoop, 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 whoop. So this would be back to 12%, 2%, 3.25, 10, 101. So we all understand how to convert decimals and percents, right? All right. So we got to zoom back in on this guy right here. B equals 1 plus or minus the rate. And whether you know it's plus or minus is whether I say growing or decreasing, increasing or decreasing, growth or decay. So we're going to do an example. I'm going to say that something is growing at 15% per year. What is B equal to? B is equal to 1 plus R. Okay, what's R? 0.15. You see? 15%'s got to be converted to a decimal. So now what is B? B is equal to 1 plus 0.15. So B is equal to 1.15. Okay, you see that? Growth, B, this is growth. The number is greater than 1. Okay, a B value of 1 means nothing. Nothing changes, flat line. A B value of less than 1, not less than 0, less than 1 means that the thing is going to go down over time. A B value of greater than 1 means it's growing. So we're going to try this. We're going to keep going because right now I'm not hearing a lot of verbal feedback, so I want to hear more of it. All right, now we're growing at 17%. What is R? 0.17. So what is B? B is 1 plus R. So B is equal to 1 plus 0.17. B is equal to 1.17. Is this growth or decay? Growth. Okay, now we're going to do another one. It's growing at 2.5%. What's R? 0.025. Remember, B is equal to 1 plus R. This is growth, so we put the plus. So B is equal to 1 plus 0.025. What's B? 1.025. Is this bigger than 1? It's growth. Okay. And now we're going to do decay. So I'm going to say like, I'm going to say that something is decaying by 20% every year. It's decreasing by 20% every year. So what's R? R is just the same thing, 0.2, right? Because I went whoop, whoop, 0.2. So remember, this time B is equal to 1 minus R, because it's decaying. So B is equal to 1 minus 0.2. So what's B? 0.8. Is this less than 1? Yeah. So that's decay. That's a signal. You see a number less than 1 in those parentheses, you know that it is decay function. Okay. Let's do one more on decay. So this time we are going to go down by 2.75% every year. So what's R? 0.0275. So remember, B is equal to 1 minus R. B is equal to 1 minus 0.0275. Can you do it on your calculator? Tell me what it is. What B is equal to? 1 minus 0.0275. Do it in the calculator. You got to get one. You know where they are, right? What is it? 0.725. Is this less than 1? It's decay. Okay, now we're going to look at some examples of exponential functions, and you're going to tell me if it's growth or decay. Y equals 4, open parentheses, 0.2, close parentheses, x. Y equals 12, open parentheses, 1.3, close parentheses, x. Y equals 200, open parentheses, 0.75, close parentheses, x. And y equals 1,000, open parentheses, 3, close parentheses, x. So all I want to hear is whether the function is growing or decaying. How about the first one? Decay. Decay. How about this one? Growth. How about this one? How about this one? Y'all understand? It's pretty easy, right? Now, I want you to tell me, for each one of these functions I've written up on the board, I want you to tell me what the starting value was. So how about the first one? Look back here. This also is the y-intercept. What's the y-intercept here? So the starting value is the y-intercept. Okay. Now, we're going to work a real example. We're going to imagine that you're earning some money by putting it in the bank. All right, you're going to put the money in the bank. You're going to have that money invested, and that money's going to earn interest. So you're going to be making money from the stock market or something. Okay. So somebody tell me a number to start with. I want Alex to tell me a number to start with. Make it an easy number, like a 25. Okay. Well, we're doing bank money, so let's call it 25,000. All right, we're going to start with $25,000. So look, the future value, I'm going to represent what the FV, future value of the bank account, is equal to, Ethan, is equal to the starting value. What was our starting value? 25,000. So go ahead and write 25,000. You should be writing it down. What do I do next? Look at the form. What comes after that 25,000? What's this called? Parenthesis. You're not allowed to have anything in between that number and the parenthesis. There can't be a plus or a minus. Okay? It's got to just be the number and then a parenthesis. Okay? Now, let's ask ourselves a question. How much percent interest is reasonable to earn by investing your money in the stock market? What percent do you... What? 2%? That's a little low for the stock market. That would be more like a savings account or a bond. 10%? 15%. 15% is a reasonable amount of money to earn per year in the stock market, okay? So that's going to be our rate. We don't write it that yet, but up here, our rate is, what did we say, 15%? So what's B? This is where B goes. B goes inside the parentheses. So what's B? Say it again, Hayden. 1.15. See, remember, B is equal to 1 plus R. R is 0.15. So B is 1 plus R. B is 1.15. So put 1.15. Close the parentheses. What goes up here? X. Yeah, that's going to represent time.
How many years?
So this is our function. I want to know how much money is in this account after 30 years. So here's what we're going to do. Turn on your calculators and clear the memories and go to y equals. Okay? Go to y equals. And type in this equation that we just created. So you start by typing 25,000. Well, let's let people catch up. So, and then I hit the open parentheses and then 1.15. Close the parentheses. And then you got to hit this symbol here. What do we call that? What do you call it? House? Carrot? Roof? You know what it is. Now, what do I put here? X. Okay, now you're going to hit second graph. Okay. Now, how are you going to find out from this table how much money is in the bank after 30 years? We're going to click down to where X is 30, right? Because X is time. Wow. Do you know what the E6 means? It means million. So how much money is in the bank account? Because that's 1.66 followed by 6 zeros. Like, not actually, I said it wrong. So I'm going to write it on the board. 1.66 times 10 to the 6th. That's what E6 means. Let's go back up to the board real quick just so we understand this. So what you're doing is you're going to take this decimal point and go 1, 2, 3, 4, 5, 6. 0, 0, 0, 0. So it's $1,660,000. Yeah, 1.66 million. Okay. Wow. So think about that, guys. You put in 25,000. You left it in for 30 years. At the end of it, you had $1.6 million. Now, I want to prove something about this. This is called compounding interest. I want to prove something to you, okay? So let's go back to y equals and clear this out. I'm going to give Tori 1 penny. Okay? Just 1 penny. How do we write a penny as a decimal? 0.01. Okay. I'm giving Tori a penny. So we're going to start constructing this equation by writing y equals, remember y is the future value. I'm giving Tori a penny. So she's getting 0.01, right? Now what comes next? Parentheses. Now what I'm going to ask Tori to do seems like a pretty simple task. I want her to just double her money every day for 30 days. Just 30 days. So how much would she need to double her money from day 1 to day 2? She just needs a penny, right? Now she'll have how many pennies? So then by day 3, how many pennies does she need to have? Then how many? Then how many? Okay, you get the idea? Tori's going to double her pennies every day for 30 days. So what number do you think goes in here? What does double mean? 2. So here's what's happening. The rate of growth is 100% growth, okay? Well, that's 1, so R equals 1, but B equals 1 plus R, so B equals 1 plus 1, so B equals 2. That's how we get to 2. But your intuition should have told you that because double means 2. So put a 2 in here. And then go ahead and put an X up there. Put this in the calculator in Y equals. So we're going to put in 0.01. Before you hit second graph, how much money do you think Tori's going to have after 30 days? 100,000? What else? Who else thinks? What else number? 200,000? Does anyone think anything else? $1,000? Okay, let's go ahead and see. And then I'm going to hit second graph, and I'm going down to 30. Ooh, what's that number mean? 1.07 E7. Let's see. So I'm going to write 1.07, and then I'm going to move this 7 times. 1, 2, 3, 4, 5, 6, 7. Remember, how much did she start with? A penny. So she ended with $10 million. Tori, can you buy us all Lambos? What would you do with the money? Lamborghini's like what, $290,000? She could buy a lot. She could definitely hook each person in this room up with a Lambo. I mean, I'd be happy with a Corolla. A Corolla? Well, she could probably buy like 100,000 Corollas. Now this is amazing. Okay, go back to the second graph thing. Look at this. Let's go back to the very beginning of all this. Look what's happening at the beginning. It's just what we said, right? It starts off, then she's got 2 cents, then 4 cents, then 8 cents, then 16 cents. Just notice that every interval, the amount of increase goes up. So first, the interval goes from 1 to 2 cents. Then it goes from 2 to 4 cents. And now there's 4, and then 8, and then it's 16, and then it's 32. It just keeps going up like this. You see? At first, it doesn't seem like much. Now, do me a favor. Go ahead and hit graph. Whoa. So this is what I mean by exponential growth. At the beginning, the picture is almost right on the x-axis. It's nothing. And then it's creeping up, and then boom, it just takes off like a freaking rocket, doesn't it? This is what happened with coronavirus. Does anybody remember how many cases of coronavirus we had in March, late February, early March of last year in Texas? How many daily cases did we have? 5 cases? What was the spread rate? Do you remember what they called the R naught? Do you remember that number? How many people did each person spread the virus to? Okay, so let's say I have the virus. All right, I give it to Chris. All right, let's say I'm only give it to one person. Now Chris is going to give it to 3 people. Chris gives it to Latravius and Stephen and Keithan. All right, now each of these 3 guys are going to give it to 3 people. So how many total people now? me, Chris, okay, Latravius, Stephen, Keithan, and then 9 more people. So that's 4, 5 plus 9, 14. So this is what super spreader is all about. Now those new 9 people, they're giving it to 3 people each, so they're giving it to 27 new people. Do you see why the schools were scared to open? Because you see, from 27, there's another multiplication by 3, so now 81 new people, and then one day later, 81 times 3, what is that? 240, 252. Do you see how quickly the whole school can have the virus? It's like 3 days. We can go from 1 infected person to the whole school is completely infected. So that's how we went in Texas from having 5 people with the virus in early March to the daily new rate of infection over 20,000 new cases. You see how big the number got? Very quick, guys. Hundreds of thousands of millions of people had it. And that's because it followed this type of pattern, exponential growth. Okay? Okay, so I think we've got the idea. I think you understand this. So we're going to jump now to our actual star problems. And we're going to start here on page 70 with this question. You see here, we're actually taking it a little easy. All that stuff we just did, we're actually now just going back to domain and range. What letter goes with domain? X. So you can eliminate B and D. So which one is it? Which inequality is the domain? A. That's because what you do is you drop a vertical line in your head down to the x-axis and circle the number. So -2, this arrowhead means it goes off to infinity, so it's just x is greater than or equal to -2. Well, that was easy. That was a real star question from the 2019 test. Would you have gotten that right? How about this one? It's asking you for the domain. Yeah, B and D can be eliminated. It's A. Okay? They're trying to trick you there on C. C would be the range if there had been a Y in there, but they're not asking for the range, they're asking for the domain. Does everybody understand why the answer is A? Good. Okay, so here we are. The population of Center City is modeled by this exponential function, which is the number of years after 2015. We don't care about any of that. Which inequality best represents the range? So what can we eliminate? A and C. Can't be A or C. So it's either B or D, but pay attention to that end function, the end behavior of the graph. It's a pointer. That means infinity, right? Yeah. So there's no cap on it. What's the answer? It's B, because D would say that it stopped at 1 million. Everybody understands why it's B? Moving on. Okay, now we're getting into what we just did up on the board. You don't have to use a calculator for this. I'm going to walk you through this. A bank account earning annual compound interest was opened. No additional deposits or withdrawals were made. The balance in the account after X years can be modeled by blah, blah, this function, okay? Now look at this function. What does the 850 represent? I don't want you looking at the answers. What does the 850 mean? It starts 850 bucks. Where does this cross the y-axis? 850. We call that the y-intercept, all right? 0, 850 is the y-intercept. What is the rate of growth? What's R? Don't tell me B. Tell me R as a percent.
0.01.
You're telling me that's decimal. I want to hear the percent. 2.5% growth, right? Is it growth or decay? I gave it away because there's a 1 in front that's growth. So now look at your answer choices and tell me the correct answer.
G.
G. Good job. B and G. Yeah. Okay. Look at number 46. Let's do the same analysis. What's the y-intercept of the graph? Where does it start? Is this growth or decay?
Growth.
What's the R value as a percent? 12. All right. Now you can answer the question. H. Number 31. Oh, look at this. Easy. It's an easy problem. That's a real problem from the 2017 test, y'all. What's the answer?
D.
Yeah, 5 is the starting value. Okay, what's the rate of growth as a percent? As a percent. 1.2. Where does it cross the y-axis? Great. Look at this, guys. We're flying through these teaks. Just looking at this picture, from left to right, the graph is decreasing. Do you see that? Does this look like growth or decay to you? Decay. So are we looking for a b value of greater than 1 or less than 1? Less than 1. Okay, good. Where does it cross the y-axis? 6. What's the starting value? Great. Okay, look at this and pick the answer. Remember what I told you. There can be nothing in between the starting value and that parentheses sign, so you can eliminate C and D. We said it was decay, which means the thing inside the parentheses has to be less than 1. So what's the answer? A. You understand? Good. Now we get to learn something cool and new and fun. You see this table? In your brain, you should be thinking stat edit. All right? So I want you to clear the memory on your calculator. 2 plus 712. Now I want you to hit stat and enter on edit. I want everybody doing this. Now go ahead and, I don't know, what page are we on? Page 74, because I'm going to keep flashing back and forth. Type this stuff in. -2, enter, -1, 0, 2. Okay, now I'm going to 12.5. Enter, 15, enter, 18, and 21.6. Enter, 25.92. Don't do anything yet. Everybody got it entered?
Yes, sir.
Okay. So make sure everybody's got it entered. Everybody got it entered? Now hit stat calc. So you're going to hit stat and then right arrow to calc and hold there. Now, up until now, we've used lin reg, right? Now we know that the lin in lin reg means linear. Then there's another one we used before called quad reg. The quad means quadratic. So what do you think we're looking for this time? Exp reg. Now, if we go back to the calculator, there is no exp reg. But if you go down below the bottom of the screen, you see it there. Exp reg, exponential regression. So go ahead and hit enter or hit the number 0 on your calculator and then just go boom, boom, boom 5 times. So what's the y-intercept of this function? What's the starting value of this function? What is the r value as a percent?
1.2.
That's the b value. Strip out the r and turn it into a percent. Remember b is 1 plus r. So we take the r, take that 1 and throw it away. Now you got 0.2. Turn that into a percent. So is this a growth function or a decay function? And how, by what percent is it growing every period? Say it to me as a percent. 20%, right? So it's growing by 20%. It starts at 18, it's growing by 20%. You understand? So let's go back to the question. What's the problem here? We were given a decimal, and we got to turn it into a fraction. So let's go back to the calculator, and let's hit second mode to quit out of this. And then let's type 1.2, enter. And then let's hit math, enter. Oh, bingo, easy. 6/5. What's the answer? B. Does everybody understand? This is cool, right? It's easy. Okay, so now we're going to get into kind of like the track meet. All right, so as a tournament goes on, you think about football, okay, and how they get closer to the Super Bowl. Do the number of teams that are competing for the Super Bowl as you get closer to the Super Bowl, does that number go up or down? It goes down. So it turns out competitions in sports represent exponential decay functions. So there's a tennis tournament, starts out with 1,024 players. Every round, half of the players are eliminated. That makes sense because there's two people playing tennis, right? So somebody wins, somebody loses. That means half the players go away. Which function can be used to find the number of players? Well, let me ask you a question. What number comes to mind when you hear half? 0.5. Great. Now this is decay, right? So we're not going to have that 1.5. It's just going to be 0.5. B is 0.5. What is the starting value? What's the y-intercept? So what's the answer here? Is it B or D? B, because it's 0.5. 0.5 means half. Remember, 2 meant double. 0.5 means half. Okay, this is easy. In the year 1900, copper sum started at 495,000 starting value. Y-intercept of this equation is 495,000. Every year since, the copper has increased. That means it's a growth function by an average of 3.25. Okay? Mark out C and D, because that we know the only thing goes up into the exponent sections in X. So wait, it's an increasing exponential growth function. So the first number inside the parentheses has to be a 1. So it can't be B because that would mean that it's exponential decay. So it must be 1.0325. That makes sense because increasing by 3.25%, 3.25% as a decimal is 0.0325. You add a 1 to that, B equals 1 plus R. R is 0.0325, 1.0325. So there it is. You see A? All right. And here we are. Remember, double means 2. Tell me what the y-intercept is. 4. Starting value is 4. It's doubling. So what does double mean? Alex, look up here. What does double mean? Look at A and B. Which one means double? This is less than 1, bro. So this would be dropping by half. This is doubling, right? So the answer is B. It begins at 4 and it doubles every hour. Do you understand how we come to that conclusion? Hey, the reason C and D are wrong is because you cannot have any math symbols in between the starting value and that first parentheses. Moving on. Look at this one. The amount of fertilizer in a company's warehouse decreases. So is this exponential growth or decay? Decay. At a rate of 3% per week. Convert 3% to a decimal for me. In your head. 0.03, right? Now subtract 0.03 from 100 or from 1 in your head. Just subtract 3 from 100. 97, right? So put a period in front of that. 0.97. All right, so it's C. So it started at 78,000. It's dropping by 3%. You see that? You didn't need a calculator for that. All right, you guys are going to get number 27 right. 29. Guys, that was a real problem. That was one of the 22 that you need to pass the test. Look how easy it took you less than a second. That was a real problem on the 2019 exam. So you just circled 29, you're done. Okay? Look here, analyze this. Before we look at those pictures, I want you to tell me something. Is this a growth or decay function? Decay. So we should expect the behavior of the graph to be decreasing from left to right, not increasing. What is the y-intercept? Okay, so look at the pictures now. What's the answer? G? Yeah. It could be J, but between G and J, we know for sure it's crossing at 10 on G. If we wanted to know for sure if it was G or J, we'd have to actually put this into the calculator and look at the behavior of the graph, okay? I want to be super sure because it might not look like it to you folks, but that thing is crossing the y-axis at 10 in J. So we need to actually look and see what is the behavior actually happening. So we're going to have to go to y equals and type 10 open parentheses. Please do this with me. 0.85 close parentheses. Housetop roof caret x and hit graph. Okay. Looks like G, right? Right. We just wanted to confirm it. All right. I think you're ready. Somebody already said the answer. Which statement is true? What's the y-intercept? It's G, right? Okay, we're done. We know, right? Yeah. Because when these true false statements come up, if you find something that's true, you're done. Okay. Now, guys, I want you to look at this here. Having a 5 in there, remember, double meant 2. So quadruple must mean 4. So this is even bigger than quadrupling. What you should be expecting is quintuple. Perfect. Quintupling. What you should be expecting is to see a graph that just shoots straight up, okay? Where does it cross the y-axis? Great. So what do you think the answer is? F. Yeah, I would choose F as well. Because G also crosses it too, but it moves up too slow. All right. Now, this is the second to the last question, and it introduces a new term for us. I know we've looked at this term before. We all get to say a bad word. So please say what I say, all right? Asymptote. Now say it all together. Asymptote. That's how you say that word, asymptote. Now look at line S. Line S is the line that forms the bottom barrier for the graph. You can tell that it will never fall below S, right? So that's the asymptote. It's the boundary. It's the fence. Do you see why R can't be the asymptote? Because you can see that eventually that line is going to go through R. T has nothing to do with the picture, and Q has nothing to do with the picture. So you knew it was either S or R, and S is the one that it hugs. So think about which one is it hugging. That's the asymptote. Asymptotes can be vertical or horizontal, but this one's a horizontal asymptote, okay? So it's H. And we're on to our final question. Is this exponential growth or decay? Decay, because it's less than 1. Where does it cross the y-axis? 1/3. So you can eliminate B. We don't really know about the asymptote. We don't know about A or C, but look at D. Does it decrease? Yeah, it's a decay function. So that D is correct. So we don't care about the asymptote. And with that, folks, you are done with 3 days of work in 37 minutes. I am really, really proud of all of you. Okay, that was good work. Thank you.